All right, I'd like to try one word problem with you that I think would be important for you to practice. Would you please write a rectangle on your paper and assume for a moment that this rectangle has an area of 700. Now, if it has an area of 700, can you tell me what the two sides are? Tell me. X and 700 over X. Very good. Because if I take X times 700 over X, these will cancel and the answer will be 700. That's what we want. Okay, now I need to know more information to be able to know how long the sides are. So what if I told you the perimeter? I told you the perimeter, you'd have a whole nother equation to bring in. So write the formula for perimeter down. And I'll tell you what the perimeter is. It's 160. I hope. Give it a shot with the perimeter being 160. I think that'll factor. And you should be able to get an answer that comes out to a real number. Otherwise, if it won't factor, you could get an irrational as in an answer that has a square root in it. It's nasty, but it still would work. You just have to use the quadratic formula. But I really would like to make it so it factors. All right, so if you have 160 equals 2 and 700 over x's plus 2 of x's, and you have to get rid of that x problem. Good. Good saying it's working. You're in negative, what? Negative 70 and negative 2. Negative times negative is positive, so I'm going to check first, make x squared, that's good. Outside and inside, make negative 30x. Last, make positive 700. Yay, it worked. Now I've got two answers. X equals 10 and x equals 70. Let's find out. So if we try, I got two different things. Are those the sides, 10 and 70? Well, it happens to give me the two answers right off the bat. This one side is 10 and the other side is 70. Right? Because then it makes a total area of 700. That's good. And is the actual 160 going to work out? The perimeter? Yep. So it told me both answers all at once. That's kind of cool. Sometimes it only tells you one. What if it told you one answer that was negative? You'd throw it out. And then the one answer that was positive had been 10. You could figure out that the other one was 70. Because as soon as you know the x is 10, you just put a 10 here and a 10 here. And you know that this is 700 divided by 10, which would be 7. So, all right. Thank you for your help in piecing that together to make it factor. That's the typical process. You have a picture, you get the sides figured out, and then you put it into a formula, and then you solve it. And since there's no calculators allowed, it's very likely it's going to be something that'll factor. Yes, sir. You have to have one positive and one negative. Maybe in this problem it's not possible. I'm going to pause for a moment here because I got something to go. So let's talk about the next topic that you have to know. If you're given a chart, I know you're not used to this. You're used to making the chart. But if you're given a chart that looks like this, and I say the function is greater than or equal to 0, and I give you all these results, can you tell me what the answer is? It's like I did half the problem for you. You just have to like take the chart, which was the hard part, and take that chart and just interpret it. That's the easy part. So why don't you tell me what you think this one is? Good question. All right. So the -3 is a 0, and the 5 is a U, which is an undefined spot. Now you know that undefined spots never work, right? So this is truly empty and does not work. Well, your final answer on this one was, where does it bigger than or equal to 0? That's where it's bigger than. And that is where it's equal to 0. So you should have said -3 and 5 to infinity with a parenthesis around the 5. You can put whatever you want around the -3. I don't care. I guess brackets make the most sense to me because it itself actually works. But if you put parentheses around it, I wouldn't like it around it. If you didn't put anything around it, I still wouldn't like it around it. But if you forgot about it, I'd have to mark it around. Okay? So be careful on that. Let's bring another one that's kind of like that. See if you can handle this one. 3-spot system. Function has to be, say, less than or equal to 0 this time. Okay, my first thought is, do the zeros themselves actually work? Yes, it says or equal to 0, so zeros can work in this situation. Those work. Where else does it work? Wherever it's less than 0, that's like negative stuff. So it's like here, and it's like here, and here. And you're going to write this out now with your parentheses and brackets and stuff. It's like -infinity up until -3, bracket, -3 works. Union with 0 to infinity, with a parenthesis around both. Now, could you stop at 3 and then start up again at 3? You can. It's not illegal, but it's not. Okay, any questions about that one? All right, next kind of problem that we need to be ready for is these fraction ones. When you got fraction issues, you multiply by the denominators to fix the fraction issues. When you're all done with these, they usually come out to be quadratics. And then you have to be able to handle a quadratic, which is what you did done last year, which hopefully you're pretty good at factoring. Or if you can't factor it, which might be the case this time, then you just got to be able to stick it in the quadratic formula. You won't have a calculator, so you won't have awful numbers. You'll be able to handle the numbers easily. Sorting. Okay, on this one, hopefully you multiplied by x and x plus 1 on all of them. And x plus 1. Okay, and this, the whole thing cancels because because if you multiply this all out, it will be that. So cancel all of it. X plus 1 cancels here, and the x's cancel here. And then you got an x plus 1 times an x plus 3. That's important that you know that's in parentheses. Did you know that? Because in any fraction, you have imaginary parentheses around the top. So now I have x squared outside and inside 3x, no, 3x plus 1x, 4x. I'm multiplying this out. And then the lasts are plus 3. And then I got this plus x times 2 is 2x. And then I got everything else except the 5 canceled. There we go. And then I got x squared plus 4x. Oh wait, 4x and 2x, we get 6x. And then the 5 comes over, minus 5. And then I think I made one that doesn't factor again. Oh, and the 3 still doesn't factor, but at least I've got it right. Okay. So now you'd have to use quadratic. So you'd use x equals negative b plus or minus square root of b squared minus 4 times 1 times negative 2 all over 2a, which is 2. And there is your answer. Ugly. Oh, does it? Really? 36 plus 4 times 2 is 8. 36 and 8 makes 42? Or 44. Negative 6 plus or minus square root of 44 all over 2. And that doesn't seem nice to me, but then I realized, oh, the 4 comes out of this. So you'd have root 4 and root 11. So that would be really negative 6 plus or minus 2 root 11 all over 2. And then the 2's would cancel. And you'd be down to negative 3 plus or minus root 11. There. Whew. It's not, yes, it's much better than I expected. Yes. Ah, you've got the card trick figured out. Go ahead. Uh-huh. Uh-huh. Okay. I'll let you think about that for a while. Okay. I'm going to move on. I'll come back to you. I just don't want to pause for too long because I'm recording here. All right. So the next question is this kind. X squared minus 16 all over x. Wait, I'm going to make it factor on both top and bottom. That's the hard kind. X squared plus 6x plus 5 is greater than or equal to 0. There is a kind of like a medium R3. Give it a shot. It's got a number line, clearly. Got a bunch of places to test. This one's going to take you a minute. So I'm going to get to There we go. All right. What you should have done on this one is factor the top, x plus 4, x minus 4, and factor the bottom, x plus 5, x plus 1. That tells me a lot of stuff. It tells me zeros, which are the things on the top, and it tells me u's, which are the undefined things. Those are the things from the bottom. So I have negative 4 and 4, and I also have negative 1, maybe be in there somewhere, and positive 5, or no, negative 5. Those are my 4 spots. The ones on the bottom are the negative 5 and the negative 1, and they are the u's. The ones on the top are the z's. And the zeros in this case work because it says or equal to, so I'm going to fill those in. Not everybody fills those in. Some people fill them in, some people don't, but you need to know that they work. All right, next part is I'm going to test the little regions. I'm going to stick in a 5 and see what happens. 5, 5, 5, 5. And it's positive, 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 positive. Have you noticed that? If you go way to the right, they always turn out to be all positive. It's true. And so then the top is positive. Right? Now, only way that could get messed up is if they have some kind of an absolute value or something. All right, and to keep us from having to test all the intervals, would you tell me where else came out positive? Did anybody else find another place? This little zone right there? Okay, so then, and the way left one? All right, and it often goes every other one, but you can't count on that. All right, so then it's from negative infinity to negative 5, from negative 4 to negative 1 with a bracket on the negative 4, and from 4 to infinity with a bracket on the 4. Do you think it works in here also? I'm going to try negative 4.5. And and that would be negative, negative, positive, negative, 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 positive, negative. That would be negative, so it's a negative in there. It does not work. All right, that is a really classic mistake, though. Check your intervals well. All right, your assignment is a review worksheet I'm about to hand you. I strongly encourage you to do all of it and